Hey guys, happy Monday. Happy first day of your Lent's vacation. I kind of miss being there for our What'd You Do This Weekend stories, but hope you enjoyed it. And hopefully it's a good Monday, just as bad as yours might be. I bet mine's worse. So anyways, what we've got here, you guys are going to start the Earth and Space Science unit. And if you haven't picked up this tracker yet, I'm sure Miss Klein will get this to you at some point today. And we are going to be looking through LT1, which has to do with calculating weight. And most importantly, looking at how that depending on where you go. So how that changes depending on where you go, or does it not change? All right. Today is the 14th, so we'll get this set up. We'll just call it calculating weight. And this is about attempt 33, I swear, of trying to find a way to get these videos to work. So with a little luck, this is the magical one. So question to ponder right off the get-go. And maybe talk to Miss Klein about it, talk to your neighbor. If we sent you somewhere else, somewhere outside of the Earth, let's just go to the moon, would your mass or weight change if you went to the moon? Okay, which one would change, or neither, both, that sort of thing? And it kind of goes back to walking down middle school memory lane. What do you remember about mass? And it could even be a throwback to Physical Science A, where we talked about the second law, where we talked about forces and masses and accelerations. And so hopefully you already know this answer. Get this set up. And here we go. So start out with some good old boring definitions. First one is mass. If you did a quick Google of it, you might hear about how it's kind of like how much stuff an object contains. So when you get to Mr. Cahoon, you'll be talking about atoms and then subatomic particles, that sort of thing. For us, we're good enough to say it's how much matter is in an object. So our definition of mass will be how much matter is in an object. When you're looking at the problems, because there will be some math associated with LT1, one of the things that you want to pay attention to is if you see the unit of a gram or a kilogram, because those are the units that scientists use for mass. So if we think about that as the definition of mass, and then before we fill out this right-hand side, I give you the definition of weight. Weight is gravity's pull on an object's mass. All right, so it's gravity's pull on an object's mass. If I told you that the unit for it is a Newton, I'm hoping you would remember, probably more from first trimester than this trimester, that a Newton is a unit of measurement for force. And remember, a force could be a push or a pull. So this is just pulling on an object's mass, which means it's the mass that is a constant between locations. Mass is just how much stuff you have. So if you have a water bottle in front of you, or a coffee cup, or whatever the case might be, if we take that water bottle and coffee cup and we sit it on the moon, the amount of stuff it contains stays the same. So the mass does not vary, does not change or vary based on location. If you've got a cup of Diet Mountain Dew here, you could take that same cup of Diet Mountain Dew and it's not going to transform, it's not going to go up or down based on if you go to the moon. But if we measure it, we weigh it, that is going to change. So this changes based on location. Okay, that's going to change based on location. So weight is just essentially a reaction to an object's mass. A bigger object pulls harder, and then a less massive object pulls less. So the moon is less massive than us, therefore it would pull less hard on you. You go to the moon, and if you took your weight, let's say you weigh 100 pounds, you can, for the most part, divide that by 3, and that's what you would weigh on the moon. So if you weighed 180 pounds, divide it by 3, you weigh 60 pounds on the moon. All right. Now, you know that one of the tricks I like to play is to make sure you can see the relationships between different variables. So we're going to do a fill in the blanker here. And I'm going to write down that mass and weight are blank proportional. And you know what it's going to be, direct, inverse, or no relationship. So think about it this way. I know the holiday season is always tough on me, and I'm irresponsible, and I have no self-control. So January, my mass goes up a little bit. All right, my mass goes up. I'm storing energy. Okay, I'm storing it. And if I'm silly enough to step on a scale in January, I will see that my weight went up. So more mass, more weight. Now after this fun-filled day I'm having today, I'm probably not going to be eating a lot for a little bit. So anything out of a straw, it'll be just wonderful. And so give me a week or so, and my mass is going to go down, which means my weight is also going to go down. Now I'm not here to do the 2 thumbs up, 2 thumbs down thing with you, but hopefully we've been together long enough that you know if they respond in the same direction, that means they are directly proportional. Okay, so mass and weight are directly proportional. That's the main concept stuff from LT1. Just, can you calculate weight first? And then, what if we change the location? What if you're not always on Earth, right? SpaceX, heck, your guys' lifetime for sure, you're probably going to be able to leave this place if you want to. So you could undergo a weight transformation, so to speak. Ms. Klein has practice sheets for you, but I'm going to put things just kind of off the top of my head on here, so you have them in your notes, and then you will work on the practice, and then you will also complete the mass and weight gizmo before you actually take LT1, so that's a little different. She will check off that you completed those, and then you will be able to attempt LT1. You have to go in that order to make sure that you've got this stuff figured out. All right, so some practice problems off the top of my head. Most of you know I've got a big fluffy dog. She'd like to think she's fluffy. She's actually pretty fat. Her name is Lily, and over the winter, we started to see she's got a serious problem. We stepped on the scales at the vet's office, and it hit 125, and it was going to keep going, so I pulled her off so that neither one of us had to be any more embarrassed than we already were. And I'm going to guess she was right around 60 kilograms, right around there. And we know that that's her mass. Okay, her mass is 60 kilograms. Now we are on Earth, and what you may remember from Physical Science A is that gravity on Earth, put it right here, is 10 meters per second squared. Remember, that was the idea. If you jump out of an airplane, every second you fall 10 meters per second faster every second. Okay, so after 1 second, you're going 10. After 2, you're falling 20. You don't have to worry about the squared thing. It's just a unit. All you really care about is that number. Okay, so if we know that she has a mass of 60 kilograms, and we want to figure out her weight, we need to know then what effect does gravity have. So gravity is 10, and the formula for weight, which is on those blue formula sheets, if something happened and you don't have them anymore, I left extras by the front door. Okay, there's some blue ones. Make sure you have one. So weight is mass times gravity. So it's just going to be 60 multiplied by 10, which means Lily would have had a weight of about 600 newtons here on Earth. Okay, about 600 newtons. Now, if we took Lily somewhere else. So I ship her off to the moon, and we look at her mass. Okay, so the amount of stuff she is storing probably hasn't changed. So her mass could still be 60 kilograms. But gravity on the moon is less than on Earth because things that are smaller in size pull less. So the moon is smaller than us, it has less of a gravitational field. It's right around 3. It could be 3.3, something like that. We're just going to go 3 for now. So let's say the moon's gravitational acceleration is 3, and we want to figure out her new weight. It's the mass again, multiplied by the moon's gravity, which means it is 180 newtons. Okay, so same dog, same chubby girl going to 2 different places, but on Earth, she weighs more because we're pulling on her harder. Just remember in Moodle, when you guys take the learning targets at the stations, everybody will be at the stations now, you don't type in the units, just the numbers. One more, okay, one more. Not too much more difficult, just it'll be a different spin. So let's say that we have the ability to land on an asteroid. There's actually thoughts in that. There's a lot of minerals and things like that in asteroids, so if we could figure out a way to mine them, it's just oodles of money. And so let's say that we hear about asteroid X, and you're going to lead an adventure there. And asteroid X has a gravitational pull, P-U-L-L, it doesn't look like that very well, that is 2.5 times that of Earth's. Okay, it's 2.5 times that of Earth. That tells us that that's one big asteroid. Okay, it has to be bigger than the Earth to pull harder. But for whatever reason, we're going to ship poor Lily off again. So she gets back from the moon, she's going to asteroid X. And on asteroid X, we know her mass doesn't change. It's still 60 kilograms. But to figure out the gravity on that asteroid, we have to compare it to Earth's gravity. So we're going to go 2.5 and then multiply it by Earth's gravity, which is 10, which means the gravity on asteroid X is 25 meters per second squared. And you guys are smart people, so you're probably already jumping ahead and going to the last step. So to figure out Lily's weight on asteroid X, it's just her mass multiplied by this new gravitational field, which is 1,500 newtons. Okay, 1,500 newtons. So Lily on Earth, 600. We go somewhere smaller, her weight is now 180. We go somewhere bigger, her weight gets bigger. All right. Now, because you guys know I'm a jerk, don't let me mess with you on this LT. If you get a question that says, Lily's mass on Earth is 60 kilograms, what is Lily's mass on asteroid Z? And I'll give you a number just to really get in your head. As soon as I ask for mass, mass doesn't change. Okay, so it'll be the same thing. All right, so you've got some practice problems to do. Mrs. Klein has the answer key, which you can compare it to. She will check you off, and you have some gizmo fun. It's a pretty easy one. And then after that, you will take LT1. Good luck.